Hey everybody, welcome to part 3 of the divide and conquer algorithms of advanced counting. In this video, we're mainly going to be talking about the uh, complexity of divide and conquer algorithms. So let's get started. So here's a theorem that's going to be helpful. So when we say A is greater than 1, then f of n is O of n to the power log base b of a. And when a is equal to 1, then f of n is O of log n. So these are the two helpful theorems that you need to remember. Additionally, if we have n in the form of b to the power of k, if we have it in this form, then we can say f of n is equal to c1 times n log base b of a plus c2, where we have c1 is equal to f of 1 plus c divided by a minus 1. And the c that we're talking about is the c over here is the c we have over here. And c2 is equal to negative c over a minus 1. So these three are important theorems that you can remember. If a is greater than 1, then you have f of n is equal to n to the power log base b of a. If a is equal to 1, you have big O of log n. And if n is of the form b to the power of k, then f of n can be written as c1 n log base b of a plus c2, where c1 is equal to f of 1 plus c by a over a minus 1, and c2 is equal to negative c divided by a minus 1. So let's look at some examples to use this problem. Let me just pull up some examples. Okay, so let's consider the binary search. As we know, for binary search, f of n is equal to f of n over 2 plus 2. So we see here that a is equal to 1, and therefore the complexity of binary search is going to be O of log n. Similarly, let's consider merge sort. We have 2f of n over 2 n over 2 plus n. So we actually cannot use these three theorems for merge sort because n over here is not a constant. So for these type of problems, we use another theorem called the master theorem that I'm just going to be discussing in a little bit. But before that, I'd like to show you guys one example where we use the case where n is equal to b to the power k. So let me just pull one of those up. Okay, so we have, see if I can type this out. So we have f of n is equal to 5f times n over 2 plus 3, and we have f of 1 is equal to 1. Find f of 2 to the power k. So this is what we're supposed to do. And so immediately let's start marking off. We have a is equal to 5, b is equal to 2, c is equal to 3, and we're told to find where n is equal to 2 to the power k. That's the question, by the way. And so we keep this in the form of the equation that we had before, and this is going to become fn is equal to a to the k times, that is terrible handwriting, just give me a second, f of 1 plus c divided by a minus 1 minus c divided by a minus 1. And we simplify that and we get 5 to the k times 7 plus 3 by 4. Again, you guys can do the math. Three by 4. Oh, yeah, this is supposed to be equal to 1. Or, no, once. This is supposed to be equal to 7, not 1. There you go. Yep, that makes sense now. And so this is what we have. And so this is big O of n to the power base b of a, because a is obviously greater than 1, it's equal to 5. And so this is equal to O of n log 5. Next, we're going to be looking at the Master's theorem. And according to the Master's theorem, I'll type this out. We have O of n to the power d if a is less than b to the power d. We have O to the power O of n to the power d times log n if a is equal to b to the power d, and we have O of n to the power log a if a is greater than b to the power d. And this is actually where we could use the merge sort algorithm, since we discussed that we obviously couldn't use it in the previous three theorems that we discussed, because the conquer part of the algorithm was not a constant, it was instead n, and so we couldn't apply our previous theorems. But for this one, we can. So let's just mark things out for merge sort algorithm. let me just write it down so that it's clear. 2fn over 2 plus 2. So we have a is equal to 2. We have b is equal to 2. And we have c is equal to 2. And another thing that we're considering here is to the power d. So we have 2, and we're expressing this in the form of, oh no, it's supposed to be b. Not this one. It's this one. So we're saying this in the form of b to the power d. And so in this case, we would have d is equal to 1. And since a is equal to b to the power d, since 2 is equal to 2, we're going to be using O of n to the power d times log n. And that is simply going to be O of n log n. Let me just confirm that answer real quick to make sure that it's right. So we're having it as equal to, and in the Master's theorem, obviously, if it's equal to, we have n to the power d log a. Since d is equal to 1 here, we just have n, and then we have log n. Yes, this is absolutely right. And so this is the Master's theorem. You guys might not have to remember these for your exams, but you could always, you just need to know these. I mean, these are helpful. Thank you.